Okay, so the rest of 7.4 is graphing these logarithmic functions, okay? We're gonna start by taking a look at parent functions. If you have the graph, which we have done already, g of x equals b to the x power, we graphed that already earlier, right? Where we had like 6 to the 12th or whatever, and we graphed points, we plugged things in, graphs, and got stuff out. When you use the logarithmic function of that, it mirrors these graphs. Do you see how these graphs are mirrored? There's a line of symmetry right here, and I could flip it and it would mirror over, okay? So something to a power is the mirror image of log base b of x. Meaning, if I can rearrange this, I can graph it and mirror it, okay? Or I can just graph this. If this is a base of 10, I can automatically put it in my calculator. If it's not a base of 10, I've got to flip it and then flip it back over that mirrored image, okay? So the graph of f of x equals log base b of x is when b is greater than 1. So b has to be greater than 1, it has to be a number 2, 4, 6, 8, whatever, something greater than 1. Over here, the graph of f of x log b of x, when 0 is less than b and b is less than 1. So what number would b be in this case? What type of, it's 0 is less than b, but b is less than 1. Or I'm sorry,
decimal.
so it would be a decimal, a fraction, a fraction. Okay, so this right here in blue is our parent function, and our red is our parent function for that, okay? So, I have two equations there, and it says graph the functions,
So
okay?
is your parent function, the, always, no, like, always like 1, or whatever number it is?
Oh, it's through 0, 1?
Yes.
Yes.
Okay.
Okay, so we're gonna graph these two things here, okay? Let's see here. We wanna graph y equals log base 3 of x, okay? Can I graph log base 3 of x?
Yes.
You can? You can plug that in your calculator and graph it?
No, because I don't have a graphing calculator.
Well,
Or a calculator at all.
no, what base is this right now?
3.
Can I graph a base of 3
No.
with log? No, the only button that works on my calculator for log is 10, okay? So what do we need to do to this function first before we graph it?
You need to find the inverse.
Yeah, I need, well, yes, sort of, yes. How can I rearrange this so that I can solve it? How did we rearrange originally? What do you do?
Yeah, x equals,
X equals what?
log 3.
Okay, you're taking it,
Oh.
okay, x equals, and you're gonna say, you wanted to say log 3 of y.
Yeah.
No, try this. Thank you. No, here's what I want. I know what you're thinking, Jason, which can work, but it can also take us down a longer path. Remember back to the first day, okay, where we would say 3 to what power gives me
Oh,
what?
okay.
Do you get what I'm saying? So if I rearrange this, I would say 3, what power would I put here? 3 to what gives me what?
X, because you don't have a,
Because you don't have what?
you don't have an, X number or something?
No, not x, it would be 3 to the
Y.
y
Okay,
equals x, yes? Okay, now listen. What is in the exponent here?
Y.
Y. So what are you plugging in for when you graph on these?
Why?
Y. You have to remember you're plugging in for y, because we usually plug in for what?
X.
X, okay? So I'm gonna have an x and I'm gonna have a y. I'm gonna plug in a 1 for y, I'm gonna plug in a 2 for y, and a 3 for y. What is 3 to the first?
3.
What is 3 squared?
9.
And what is 3 cubed? Okay? So when you go to plot these, you had to think backwards because you plugged into y. Do you get what I'm saying?
Yes.
Okay. So I have 3, 1. Actually, let's count by 3s so that my life is easier. And we'll worry about the 27 one in a second. So I have 3, we're gonna count by 1s on this one. 3, 1. I have 2, and I have 9, 6, right? Or 9, 2, I mean. And then I have 27, and I have 3, so 15, 18, 21, 24, 27, right? So this is what my graph would look like, correct? Okay, so I have a graph that's kind of going like this. Now, I have a problem though. I have a problem. There's another way that we can do this, and it will make it easier, because if we do it this way, we still have to do another step to it, okay? If we use something called change of base, okay, formula, which they show you next section, but if we use change of base formula, we can cheat the system and make this easy, okay? So change of base says this. When you use change of base formula, we're gonna set it up so that it has a base of 10, so that I can plug it in my calculator, okay? I wanted to show you this way first, but we're going to use change of base because it will just be easier for us. Okay, so if I have change of base formula, I'm going to focus on, let me erase this because we still have to flip that. I'm gonna focus on the base. What is my base of this equation right now? 3, okay, 3. And what is, okay, so 3 is my small number here,
Yes.
x is my large number, okay? So I'm gonna say y equals, and you're gonna say log of x over log of 3, okay? Here's why. If I change it to log, what base does it have? 10, okay? So if it has 10, can I plug something in here and divide it by, can I plug in log 1 and divide it by log 3 and get a y out? Yeah, so I don't have to flip things or think backwards, okay? So let's plug in a 1, let's plug in a 3, and let's plug in a 9, okay?
So,
What?
on our homework, do you want us to do both ways or just?
Let's do it this way.
Okay.
Oh,
Okay, so if I plug in a 1, then I'm gonna plug into my calculator log 1 in parentheses, divided by log 3 in parentheses, and what do you get out? You're gonna have to do it on your calculator. You guys need to practice on your calculators.
What'd you say?
Log 1 divided by log 3.
Drew, catch.
I
it
got
might be out of
0.
my house, I don't know.
You get 0, beautiful. Now, let's plug in a 3. What happens when you do log 3, parentheses, divided by log 3? What do you think you're gonna get?
1?
Oh, 1.
Beautiful. Now let's do log 9, parentheses, divided by log 3. What do you think you're gonna get?
3.
Mm-mm.
Not, yeah, that's right.
Because remember, these are exponents, so 3 to what power gets you to 9?
2.
Yeah. Okay, so this is much simpler. So my graph will then be 1, 0, it will be 3, 1, and it will be 9, 2. 9, 2.
So we did the same thing the last time, it's just instead, we just did it.
Yeah, except for last time, it was more stretched out because we did it more complicated. Like, personally, I think this is less complicated. Because you remember that you're plugging into X, you remember that you're getting a Y out, so your brain doesn't get tricked up.
So we're just using this method only, or not?
I would use this method if I'm you. They don't teach you this method till next section in 7.5, so I'm just telling you it early so that you can use it tonight for graphing. Okay, does that make it easier? Whatever is larger always goes on top of my fraction, and whatever is the smaller one goes on the bottom. Yes.
How will we know what number to use for X?
You just plug numbers in, it doesn't matter.
It doesn't
I
matter
chose
which
1,
ones.
3, and 9 because this was a 3 down here, so I chose multiples of that number because I knew it would come out even.
Oh, okay.
okay?
Would that be
So
that?
that'd be a case for like, we choose 2 or 4? or-
Yeah, like if you have a 4 down here, I would choose like 4, 16, and something else, like multiples of 4, because this is powers, right? So
Yes.
3 to the first, or 3 to the 0 is 1, 3 to the first is 3, 3 squared is 9.
So just do something that goes with. the
Yeah,
number.
that's what, personally, that's what I choose, but you can plug in 1, 2, 3, you're just gonna get decimal answers out.
Okay, you want,
I just like whole numbers if I can, you know? Okay, now, down here, how would I rearrange this so that I can plug numbers in? It'd be y equals what? Log of what?
X
Over,
log of 1 half.
beautiful. What do we wanna plug into x? Pick some numbers for me.
Do 1.
Okay. Let's do 1, let's do 2 and 4. Just for the heck of it, we'll see what it's like. If I plug in 1, that means I have log 1 divided by log half, what do you get?
0. I have 0, is that right?
You got 0?
Mm-hmm.
That is correct.
Yeah,
What
so
happens
wait,
when you-
Wait, so one
Oh.
is always gonna be 0.
Well, because it's saying this to the 0 power gives me,
It's gonna get you.
what?
So I'm starting backwards.
yeah,
So like it's
Yeah,
gonna
that's
give
gonna
you,
be a headache.
yeah,
so you don't even need to.
correct, unless there's something like this over here where we have shifts and stuff, we'll talk about that in a minute. Okay, now what about, log 2 divided by log 1 half? So it's essentially saying
I know. Is it
1 half to what power gives me 2?
I had -1.
Yes. This graph should face down, it has a half. Because look, 1 half to the -1 gives me 2, because it flips it, right? Okay, now what's log 4 divided by log 1 half?
-2.
-2, beautiful. So then I plot those points.
Bro,
1, 0, 2, -1, and 4, -2. Here's my graph. Cool? It's gonna run along here. Now, domain of these graphs and range of these graphs, okay? Let's talk about that for a second. My domain, it's not gonna cross over this y-axis, so my domain is 0 to infinity.
Also, all the numbers.
No,
Oh.
0 to infinity,
Oh, so-
all positive real numbers.
Oh.
My range, however, though, what's going on here? Is it going up forever?
Yes,
Is it continuing down forever? So my range is what?
all real.
All real numbers. The only time it changes is when we get over here, and we're gonna talk about that. Okay, now, let's graph this, okay? And let's focus on this portion, right here. Okay, remember how we focused on a portion on my other ones and then we shift it afterwards? We're gonna do the same thing, okay? We're gonna focus on that and then we're gonna shift. Okay, so if I focus on that, how can I graph log base 2 of x? How do I need to set that up to graph it? Y equals what?
Log of X over log of.
Beautiful, log of x over log of 2. So let's plug in numbers. What numbers do you want to plug in? What numbers do we want to plug in? 1 and what else? 2 and what else? Give me 1. And 4? Beautiful. If I plug in 1, I have log 1 over log 2. What do you get? What should you get all the time?
0.
Beautiful. If I plug in 2, log 2 divided by log 2, what are you going to get?
1.
Good. And if I plug in log 4 divided by log 2, what are you going to get?
2.
I'm sorry. No. Yeah.
Yeah.
No, you're not going to get 2.
Huh?
Oh, wait. Yes, you are. I'm being silly. Yeah, you get 2 because it's saying 2 squared is 4, right? Okay, so we plot these points. 1, 0, we plot 2, 1, and we plot 4, 2. What do you think we need to do with these points now?
Shift.
Shift. What are my shifts that I'm doing?
You're gonna go left,
Oh.
Yes.
right one.
So
Okay.
minus-
Up one, up one.
minus 3, minus 3, minus 3, and plus 1, plus 1, plus 1. Now do you see why we're doing this the same for every type of graph?
Yeah.
We're just gonna graph them and shift them,
This
graph them
seems
and shift
pretty
them. It does seem easier? Good.
Just not waste my time.
So my new point becomes negative 2, 1, right?
Yep.
My new point becomes negative 1, 2, and this new point becomes 1, 3, yes? So negative 2, 1, and then negative 1, 2, and then 1, 3. Now, domain and range. Domain. What tells me my domain? It's right here.
Yes.
What tells me my domain? Domain is what axes?
Exactly.
The x. So what is my domain?
3.
So x is,
Greater than,
Wait,
wait,
Domain.
yeah, x,
oh, you go minus 3, minus 3, minus 3, but you went. Oh, wait, okay, never mind.
okay.
Never mind.
So the domain, okay, and the range, we're talking about that. Domain has something to do with that 3, okay? X has to be what with that 3? X has to be, we're gonna talk about that in a second. X has to be
greater than
greater than, not 3, what number is it? Remember, it's opposite.
Oh, negative 3.
So x is greater than negative 3.
Okay.
My range is what? Y is greater than what?
One.
Y is greater than 1. No, wait, I lied. Your range is not y is greater than 1. What did I tell you about your range in all of these?
All those numbers.
Always all real numbers on these. Okay? So, I don't even have to go.
So
forward.
basically the domain range switch from.
Yes.
Like the last time.
The last time,
'Cause, like,
domain
domain
was
is-
always all real numbers and range is what we looked for. On these, on logarithmic functions or on natural log functions, the domain is what you look for, the range is always all real numbers. Now, here's the deal. Do you see how I put a dotted line through this negative 3?
Yes.
This is called your asymptote,
What?
okay? An asymptote is where a graph will never cross. It's going to come close to it, but it's never gonna cross over it. It will just keep getting a
Okay.
smaller decimal,
That makes sense.
which is why x has to be greater than negative 3, because it can't cross over there. So, your asymptote,
So it's just 1 over.
All this
if I'm spelling this right, give me a second.
It's like the same thing.
That sounds made up.
A lot of work sounds made up.
Okay,
Everything is.
your
made up.
asymptote
You don't know.
is x equals 3, okay? They're gonna have you start identifying that in these graphs as well. Your asymptote goes with your domain.
Negative
It's
3.
always the opposite.
Oh, I'm sorry, negative
Oh,
3, Drew.
okay.
You're right, you're right. Thanks, Drew. Okay, so if x is greater than negative 3, my asymptote is the line x equals negative 3. My range should always be all real numbers. So on your graph, I need you to sketch that asymptote in as well, okay? Okay? That's what we're working on today. The shifting shouldn't be anything new. It's exactly the same as how we shifted before.
I think I'm going to get confused.